Within the Iowa Technology Institute, the BioMOST Lab in the College of Engineering is researching tools to better understand diseases in the cardiovascular and pulmonary systems and develop devices to help overcome challenges in these systems.
At the biomechanics of soft tissues lab, we develop tools for plumbing the human body. Like pipes in our homes, the pipes in our bodies too need plumbing sometimes. Pipes like arteries and veins of the cardiovascular system, airways of the lungs, intestines, that's all. These pipes can clog, blocking flow, or they could balloon and burst, for instance. We bring together ideas from engineering mechanics, this is the study of forces and motion, along with ideas from medical diagnostic imaging, material chemistry, and of course biology to better understand these disease states and to develop ways for treating them. The lab itself is a sandbox-like space where we'd like to tinker with mechanical and electrical tools in order to build apparatus and prototypes that we could use to do our studies.
Engineering students are getting hands-on research experience within this lab.
My research project is on using computational modeling and image processing methods to study the mechanics of the lung. Specifically, we are looking at how the different lobes of the lung slide against each other and how that might help people breathe, and how people who maybe don't have good sliding between lobes might be experiencing worse breathing, and how we can maybe leverage that to better understand the lungs and treat them. We are in the pretty early basic science phase of things, learning how sliding between lobes affects the lungs. And that's because ultimately what we want to do is we want to make better lung treatments and better lung diagnoses, but that requires knowing more about the mechanics of the lung to begin with. We can't answer those more applied questions that are going on in the hospital until we have a really good fundamental understanding of the mechanics of the lung. And this is giving us another step towards that so that we can start doing things like safer mechanical ventilation or better disease characterization and diagnosis.
Students like Marco Nino got their start as an undergrad and is now pursuing his PhD.
So my research involves measuring blood flow in the body, and it's unique in that we're taking a non-stereotypical approach in which we are using electrochemistry, principles of electrochemistry, to lock in on a more sensitive and specific method of measuring blood flow. So there's always been fairly consistent ways of measuring pressures in the body, but flow has always been a great challenge for clinicians. Till this day, there's not a perfect method or a gold standard to say. There is a clinician favorite, the thermodilution, but we think that we can disrupt that and create something innovative and more reliable for clinicians and doctors. I think this graduate research really allows me to dip my feet into what it's going to be like for, let's say, 10 years down the line.